Hello and welcome. Dr. D here from the Bridgeton School District in Bridgeton, New Jersey. For our science lesson today, I am going to need your help. I'm going to need everything that you know about heat, phase changes, and air. Who would think air, right? So I was doing an experiment since most of us, well, all of us actually are home due to the coronavirus or the COVID-19. It's the same thing. They just have two different names for it. So I'm thinking of all these science things I can do and things that happen naturally. So I don't know what made me think of it, but I decided to do an experiment using a can, a soda can. And I used three things. I had heat, I had water, and I had air. And this is what happened to the can. What in the world happened to make the can implode on itself? I didn't squeeze it. Oh my God. I didn't squeeze it and try to crush it. I didn't stomp on it. I didn't put it in the can crusher. All I did was use heat, water. That's all I did. And then this is what happened. So I'm going to need your expertise and I'm going to need your knowledge and a little bit of information that I'm going to give you so that we can try to come to a conclusion as to what made this can implode on itself. Are you up to the challenge? Are you ready to help figure out what made this can implode? Well, before we go any further, I'm going to show you a video of what I did during my experiment and how the can imploded, and then I'll see you again in a few minutes. Get ready. Wasn't that awesome? Did you see that? At first it really startled me because it did make me jump because I did not expect that to happen. So we're going to try to solve the mystery as to what made the can implode. But before we do that, we have to do what Dr. D likes to call brain exercise. So we have to warm up the brain. How many of you out there do a sport, whether it's soccer or football or baseball or softball, dance, any of those things? What's the first thing you do before you actually play? What's the first thing your coach has you do? Warm up, right? They have you do jumping jacks. They have you do stretches to stretch your muscles. You have to touch your toes, twist, all kind of things. Push-ups. Miss D can't really do a push-up, but that's okay. They have you do all of these things. Why? Because it warms your muscles up so that you can be more effective and more efficient when you're actually playing your sport. But we have to remember, we have to do the same thing to the brain, the exact same thing to the brain. So what we're going to do is we're going to do a brain exercise warm-up, okay, for you to do to get ready, because you're going to be thinking super hard, right, to try to help Dr. D solve this mystery. I can't wait. Here we go. Brain exercise number 1. Welcome back. Well, I hope you enjoyed Skylock Fox, one of my all-time favorite puzzles. I still do Skylark Fox every Sunday with the Sunday's paper. I always enjoy it. I'm a big puzzle fan, so I do crossword puzzles. I do those 1,000, 2,000 piece jigsaw puzzles. I do Sudoku. Anything, crossword puzzles, word search, any of those things I do. I really, really enjoy doing them. But you did it because you're trying to get the brain ready to solve this mystery. How did this can implode with Dr. D not touching it? I don't get it. We have to figure this out. So the first part in solving the mystery is you're going to have to use your listening skills. Because when you listen, you're going to hear or listen for clues to help you answer 4 very important questions about air. Number 1, does air take up space? Does air have mass? Does air do work? And does air have pressure? So those 4 things we need to have answered before we can possibly solve the mystery. And the story that you're going to listen to, that I'm going to read to you, is called Wilbur's Space Machine by Lorna Ballion. This is a story of Wilbur and his wife Violet. And a lot of things happen that have to do with air. And by listening, there are some good clues in here to help you answer at least 2 of the 4 questions. So, get a piece of paper and a pencil, open up those ears, and listen to the story and see if you can find the answer to at least 2 of those 4 questions. After I'm done reading, we'll revisit it, narrow it down to the 2 questions, what their answers are. Then we're going to roll into 4 mini labs. Now these labs, I will give you the materials once I'm done the story, because if you want to do them alongside me, that would be great. If you don't have the materials there, it's no big deal. You can always, later on get the materials and do them with your parents, because Dr. D is a strong believer in using everyday materials to do science. You don't need fancy machinery and equipment to do really awesome science. And so that's what I want you to understand. Science isn't everything that you do. It's everywhere. It's in your house right now as we're speaking, because all the materials that I have are in your house. And those materials are going to help us solve the Can Crusher mystery. Okay? So get your pen and paper, and I'll see you when I start the story. Okay, so we've moved into the living room where it's a little bit more cozy. And we're going to be reading the story Wilbur's Space Machine by Lorna Ballion. Now remember, the purpose of reading the story is to be able to listen for things about his space machine and connect it to air and to our 4 questions behind me. Now our 4 questions are, does air take up space? That's really, really, really important. Does air have mass? Does air do work? And does air have pressure? Because those 4 questions are going to help us figure out what in the world happened to make the can crush. Because remember, I didn't crush it by hand. I did an experiment. And then that was the outcome. But I'm going to need you to be able to help me decide what actually happened scientifically for that to happen. Now, in order for that can to crush, there were a few things involved. There was heat involved. There were phase changes involved. And it was also something to do with the air. Was something involved in that. So those 3 things together caused that to happen. But I'm not exactly sure. And that's why by me working with you, hopefully we'll be able to come to a conclusion as to what crushed that can. So here we're going to go with our story, Wilbur's Space Machine by Lorna Ballion. So Wilbur and Violet lived all by themselves, smack in the middle of nowhere. They lived simply in clean, peaceful space. They were happy with their lives. In the spring, they planted their garden. During the summer, they tended their plants. When autumn came, they stored their harvest. And all through the winter, they read books and slept. But gradually, so gradually, Violet and Wilbur hardly noticed. Other people moved into their valley. A family here, a family there. And it looks like it's getting a little hairy. Okay, a lot of people are starting to move in. There's houses back there. Oh my goodness, what's going on? Until they were surrounded by a whole crowded village. There were people, pets, houses, stores, factories, roads, bicycles, motorcycles, buses, and trucks. Take another big breath. There was smoke and smog and trash, garbage. And there was Goji. So do we remember what it looked like first moved there? Right? It was hardly anything. There's nothing else there. Just nature. And then now, there's tons of houses everywhere. And then Goji. This is Goji. Where is he at? Right here. That's Goji right there. Our lovely valley is polluted, said Wilbur sadly. We don't have clean, peaceful space anymore. No, dear, but we have each other, said Violet. We have each other. And we have Goji, said Wilbur, as he scowled at the boy who lived next door. So there's the boy lived next door. We can see him here, right? And they said they still have each other. In the spring, they planted their garden, but Goji trampled it. During the summer, they tended their plants and cleaned up litter left by Goji. When autumn came, they stored their harvest, whatever Goji hadn't taken. Winter arrived, but this time, Wilbur couldn't sleep. He was too unhappy. So we have what happened in all of the different times of the year. We have the spring, we have autumn, we have summer, and we have winter. Wilbur missed clean, peaceful space. They had to have more space. Lots more space. Suddenly, Wilbur had an idea. Wilbur jumped out of his bed, hunted for his tools, and started to build a space machine. Aha! Wilbur was so excited. He hardly slept all winter. He planned, he measured, he whittled, he sawed, he glued, he drilled, he pegged, he hammered, he tacked, and he tied. All winter long, because Wilbur wanted space in his house again and all around him. So he was going to build a space machine. Space machine? Until in early spring, his stupendous space machine was finished. You want to see it? That's his stupendous machine. Here it is. Right? Oh my. Wilbur started cranking with a fury. Cranking it and cranking it and cranking it and cranking it. And his machine worked just fine. There was a great amount of space billowing into the air out of the nozzle, just as Wilbur had wanted it to. But all of that lovely space just went whooshing back to where it came from. That wouldn't do it all. What do you think his space machine was really making? Wilbur, dear, let's put the space into containers so it can't get away with us, advised Violet. So they filled all their boxes and bottles and jars and pans and kettles. Space was crammed into bags and socks and pockets and pouches. Oh my. Right? What do you think they are actually putting into all of those items? And look who's looking out the window. Can you see him? Who's looking through the window? Doji. What we need are balloons, Violet, cried Wilbur. They cranked huge amounts of space into every balloon that Violet could find. There was nothing left to fill. Wilbur was so discouraged. They had great amounts of space. That was true, right? And we can see they had tons of space. They put it into jars and bags and socks and boxes and containers. They put it into balloons. But they didn't get more space. I wonder if that has to do with any of those 4 questions. They had more space, which we know is what? Air, right? But the house was crowded. So which one of those 4 do you think that proves? There was nothing left to fill. Wilbur was discouraged. They had great amount of space. Like I said, that was true. But somehow they didn't have any room to wiggle. So if they didn't have room to wiggle, can we now answer? Can we now answer one of those questions? This is all the balloons, right? This is all of the balloons. Wilbur was very tired. He had been cranking his machine for months. Violet squeezed him out of the door and tucked him snugly into the hammock. Never mind, dear. You rest for a while, she whispered and kissed him. We still have each other. Wilbur slept while Violet tried to rearrange all of the packed up space in their little house. So while Wilbur is sleeping, she's tying the balloons around the house, and we got our guy there. I tell you, he doesn't miss a trick, right? It's a lot of balloons going around that house. I wonder what's going to happen. The summer sun rose hot and clear. Hot and clear. Wilbur dreamed he had clean, peaceful space all around him. And then he awoke to discover it was not a dream. Violet, look! We have clean, peaceful space again. What do you think happened? Anybody guess? Look at that. They're way up high. There's the bird right over here. Oh my goodness. Uh-oh. Who else is there? You see him? Goji. What do you think happened? The house moved up, right? Does air take up space? I think we answered that question. We're going to prove it in one of our mini labs. Does air have mass? I don't know if we had any good information about that yet, but we will when we do our mini lab. Does air do work? Does air do work? Did the air do work? Did it move something? Does air have pressure? So I think for sure by now you already know the answer to 2 of those 4 questions. Don't you? We certainly do, my dear, sighed Violet in response to having so much more clean, right, space. Looking at the garden far below, because she's standing on the house and she's looking down like, oh yeah, we have a lot more space, all right. And we do still have each other, said Violet. And we have who? Goji, said Wilbur. Oh dear, his mother will miss him. What can we do, said Violet. Wilbur tells her, I'll think of something. What do you think he did? You think he's going to keep Wilbur with him? Not Wilbur. You think he's going to keep Goji with him? And he did. So what did he do? He put the balloon to work again. But the work this time was to put Goji back down. So 2 of the 4 questions in this story we can definitely answer. If whether air takes up space. Because right now in the story it looked like air did take up space, because the more they put the stuff in containers and in balloons, they had less space within their house. So if that was the case, air had to take up space. They didn't get more room, they got less room, which means air took up space. But I want us to prove it, which is going to be one of the first labs that we do, is to prove that air takes up space. The second thing that we can say for sure between these 4 questions that I have behind me is number 3, where it states, does air do work? It looked as if air did do work, because air was able to lift the house up, but air was also able to bring Goji back down safely. Okay? So 2 of the 4, we have some kind of inclinations in the story that could possibly happen. But this is a story. What we need to do now is we need to prove it. So we're going to go back into the kitchen and we're going to do a 4 mini labs. And then I'll tell you what materials that you need. Okay, so hopefully you were able to get some of the materials for demonstration number 1, which is air takes up space. I think you pretty much know the answer to that based on Wilbur and Violet. Remember when they were putting his awesome, spectacular space machine was really generating air. Okay, so as they were taking the air and putting it into containers and putting it into balloons, did they have more space in their house? No, they had less space. In order for you or anything to have less space, something has to take up space. So I believe we already know that air does take up space, but let's prove it. So we're going to take the paper bag first, and you're going to open it, and I'm going to go to you and say, what do you see in the bag? What do you see in the bag? And you're going to say, nothing. And I'm going to be like, wrong! You're wrong! There is something in that bag. And then you take the bag and you close it very quickly. And what happens to the bag? It puffs up. It puffs up because there's something in it. And if you push, you're also going to see, now don't push too hard, but if you push, you're going to see, you can feel it squishing like you're pushing something out because you're pushing the air out of the opening. So this is one proof that air takes up space. Now for the second part of the first demonstration, which is actually one of my favorites, and it's an awesome trick that you can play on your parents or your siblings or your friends. You take a plastic bottle and then you take a balloon And you're going to put the balloon in it. But first, what I'm going to do to prove to you, and this is what you want to do, you want to say, I'm going to prove to you something, and I'm going to blow up the balloon so that you can see that the balloon really, really can be blown up. So we're going to blow up the balloon. Okay? So it's proof that it does blow up. Then what you do is you take the balloon and you place it into the bottle, and very carefully you stretch the opening of the balloon over the top of the bottle. Okay? Then what you have to do, you see the balloon is in there, right? Then you're going to try, you're going to tell the person, or you're going to do it yourself, and you're going to say, try to blow the balloon up. Now, if you notice, you can see the balloon expand inside, but it doesn't get much bigger, right? I'm going to do it again. It didn't get much bigger. But then what you do, that they don't know you did, is you take a pin and you pop a hole into the bottom of the balloon. Now, this is why you want your parents to help you so you don't stab yourself. I've stabbed myself many times, and it is not fun. Okay, because sometimes the plastics are really, really thick, and you'll go to push it in, and then you'll slip out, and then you'll stab yourself. So make sure someone helps you with this. But you put a hole into the bottom. As you can see, I put a hole in there. You don't tell anyone. So when you go to do the trick, you would do what I just did. Tell them to try to blow it up, and you would show them. But you're covering the hole. Okay? And they're not going to be able to blow it up. They're not going to be able to blow it up because there's air in the bottle that's pushing up against it, the balloon, so we can't move. That's proof that air takes up space. Now, you're going to have your special bottle that you made, because you're going to have another bottle for the other ones that doesn't have a hole in it. And you're going to be like, what do you mean you can't blow up the balloon in the bottle? Watch. And as you can see, I'm about to pass out, but as you can see, the air does expand within the balloon. And the reason that the air expands within the balloon is because you have the hole in the bottom of the bottle. As you're blowing air into the balloon, it's pressing against the air in the bottle, and it's being pushed out through the bottom, through the hole. So that is proof that air takes up space. So Wilbur and Violet got it right. Air takes up space, and that explains why they didn't have any room in their house. Now, I'm going to list the materials for demonstration number 2, give you some time to find those materials, and I'll be right back. You were able to find the items. You might not have a yardstick at home, so you might just really be watching this with me. But if you do, and you have a yardstick and 2 balloons, and of course, tack again. And remember, have your parents help you with this. So what we're going to try to do is we're going to try to prove if air has mass. So I blew the balloons up ahead of time so I wouldn't have to pass out in front of you, because I almost passed out when I had to blow that balloon up in that bottle. So just as a little hint on that, you might want to put 2 holes in the bottom of the bottle, so therefore it won't take you so much effort to blow the balloon up inside the bottle. So what you want to do here, which is a tricky part, is you have to find the part where they are balanced. And this is the one part where it's a little tricky, okay? So it's not going to really matter if you blow the balloons up to be the same size, because you're going to find the point where it's what they call a fulcrum is, where that middle point is, where it's balanced on both sides so that your finger becomes a fulcrum. And then you're going to see that they're balanced, pretty much balanced. It's going to wobble a little bit. Then what you're going to do, so right now, whatever they have inside, they are equal. I'm going to pop one of them, hopefully, and if the balloon or the air in the balloon has mass, what do you think will happen? Think about yourself on the seesaw. If you're heavier than your brother or sister and you're on the seesaw, what happens? If you're heavier and you jump on that seesaw, you go down and your sibling would go up. If the other person is heavier than you and they jump on the seesaw, they go down and you go up, right? That's because your masses are different, okay? Your weight is different, actually, because weight has to do with gravity. So what we're trying to do is we're trying to find out, is that same thing going to happen here? Because if it does, then it's proof that air has mass. If I pop it and it stays balanced just like this, then it doesn't matter. It has no mass. But if I pop it and it goes like a seesaw, then that is proof that air has mass. Here we go. You see it tip? It tipped over. We'll do it again in slow motion. So you have been working so very hard, okay? Went through 2 demos as we continue our quest to try to figure out what made this can crush. We have 2 more to go. Does air do work, and does air have pressure? But I think it's time for a brain break. My brain needs a break, so I know your brain needs a break as well. So, do you know which one doesn't belong? Is there an answer, or is Dr. D just trying to trick you? I guess you'll have to wait and find out. In the meanwhile, I'll put up a list so you know what you need for the 3rd demo and give you an opportunity to get that. At the same time, give you a brain break. All right? See you in about 2 minutes. Now we're going to work on demo number 3, which is air does work. So what we're going to try to do now is to find out if air does work. Who remembers from the story how we proved air did work? Anyone remember? If you said the house going up in the sky with the balloons, then you are correct. Although we know in real life, put balloons around your fence, your house is not going to float up to the sky. But the fact that we're trying to prove is that air does do work. When something moves up and down, and energy of whatever is exerted for something to move up and down, then therefore it's said to do work. So that was one way we proved that air did work. The other way we proved air does work is when he lowered Goji down to the ground with the balloon. So what we're going to do now is we're going to do a very simple experiment. So hopefully you have your book or textbook, you have a baggie, you have a straw. I taped the opening here, so the straw is taped inside the bag. So I put tape there so that you can see the tape. And what I'm doing now is I'm putting duct tape on the baggie. And the reason I'm doing that is because to keep the books from sliding off of the plastic. You don't have to do this part, but you can if you want. So as you can see, I already put 2 on. I'm going to put a 3rd one on because I want you to be able to see what happens to the books before they slide off. So now I'm taking 3 books, pretty heavy books, 3 of these books, and I'm going to place the first one, press down really good. Okay, I have the straw sticking out. Do you see that? So I have the baggie, which is on the bottom. They're taped. The bottom book is taped. And I have the straw taped inside because I'm going to blow into the bag. Now when I blow into the bag, what's going to happen? The bag is going to fill with air. If I'm able to move the books up, then I can prove that air can do work. If I blow in here and nothing happens, then I can safely state that air cannot do work. Okay? So I have this. I'm going to put it over the edge, make sure my books are on there, and now I'm going to blow into the straw, and you are to watch what happens to the books. Right? You see that? I'm going to do it again. You know what I'm going to do? I'm going to put some tape between the books as well. I think that is a good idea. Before you do this at home, you make sure it's okay with mom and dad for you to put tape on the books because you can destroy the books, rip the cover. If it's a paper book and you're using duct tape, you can destroy the book. I'm doing this because I know I'm not going to mess up the covers because I'm going to take it off very carefully. There. We're going to try it again. Watch the books. Does air do work? Will these books go up or will nothing happen at all? The books moved, so therefore air does work. Now get ready for demo number 4, which is my all-time favorite. Get your materials ready. See you in a second. Okay, here we are. We're on the fourth and final demonstration. Then we're going to take all of the information from these 4 demonstrations to be able to solve the can imploding mystery. What crushed the can? So this demonstration here happens to be one of my favorites, and this is also something that you can do to your friends and family, okay? To awe them and like, oh my gosh, how did that happen? So I have water in my container. I have a bowl here just in case something happens and it doesn't work, so I don't want to make a mess down here. I'm in the basement, don't forget. I have a glass, and I have a disc. I use a disc one, but you can also use an index card. Okay, so you can use an index card. So what you do, now remember, we're trying to find out if air exerts pressure, because what you have to remember is that air is all around you, and air does not just press, it's not on top of you. Air is under you, it's under your feet, it's under your armpits, under your legs. Air is everywhere and in every single direction, okay? It's everywhere, all right? That's what you have to remember. Air is everywhere. Up, down, sideways, up, down, coming in, everywhere. I think I made my point, right? Okay, so we're going to find out if air has pressure. This is a crucial part of the can crusher. So listen very carefully. This part is huge. That's why Dr. D saved it for last. So I'm going to pour some water in the container. About half is good. I'm going to take my disc. I'm going to place it on top. And then I'm going to turn it upside down, holding it on there, right? If air has pressure, when I take this off of this hand, it should stay. Because that would mean that air is pressing up from the bottom. Because remember, air is everywhere. Let's see. You ready? Ah! Check it out. It stayed. It stayed. Okay? What that means is air has pressure. Because what is happening is the air that's on the bottom, that's underneath this, is pushing up against this disc here and is keeping it attached to the cup or to the glass. That proves to you that air has pressure. That is crucial, absolutely crucial in understanding the can. It has a lot to do with pressure. Isn't that awesome? Check it out. Now, I'm going to turn it sideways. What do you think is going to happen? Why did that happen? Because air is pushing this way as well. Pretty awesome, right? Air does have pressure. And that ends the 4 demonstrations. And I want to thank you so much for helping me out. So I'm going to clean all this up. And then we're going to get ready to explain what happened here. Stand by. So now we did so many experiments. Now we're ready to take everything, put it together so that we can solve the mystery. So what I'm going to do is I'm going to show you each step and then explain each piece using what we learned from Wilbur and Violet, what we learned from the 4 demo experiments, so we can figure out why this happened. Okay? So first thing I'm going to do is I'm going to put on my safety goggles to make sure that I'm safe. And let me explain to you what I have. I have an empty can. I have a hot plate that's extremely, extremely hot. I have water. I have ice water. This is very, very important when we talk about the phase change. And I have tongs because the can is going to get very hot. So one of the first things I'm going to do, I'm going to pour some water. And if you notice, I'm not going to fill up the can. I'm I'm going to put just enough water in it because it needs to change phase. It needs to change from a liquid to a gas, also known as water vapor. That's part of the phase change. That's where we need the heat. Okay, we need the heat because that's how we change phases. Heat, cold. Now I'm going to put it on the hot plate, and I have to let it get very, 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 very hot. It has to boil. The water has to change phases to become a gas, and we do that by adding heat. So that's what's happening here, and we're going to wait for it to boil. Okay, now this is really, really hot. The water is turned into vapor. I don't know if you can see it, but there's steam coming through the can. So now what I'm going to do is I'm going to take the hot water that's in here that's now vapor, because we change phases, and I'm going to immediately place it into ice cold water. It's going to go through another phase change, and it's going to go through the phase change very, very quickly. Here it goes. Oh, gotta be careful here. I do not want to burn my hands. And 1, 2, 3. There we go. It imploded on itself. Now let's talk about what happened and put all the pieces together. Here we go. You see the can? This is what happened to that wonderfully round can. So now what we're going to do is I'm going to talk about each phase connected to what we learned about phase changes with the heat, to the 4 mini labs that we did, because air pressure is very, very important, so that we can figure out why this happened. Phase change, heat, and air pressure. Here we go. Here's the explanation. Okay, now, in order to understand what happens with air pressure inside a can, I have a closed can here. Okay? So, did it ever happen to you where you shook a can up, or you didn't know that the can was shaken, and then you open it up and it explodes everywhere? That also has to do with the air pressure inside of a can, the same that had to happen when we did the implosion of the can, but what I did was reversed. So if I were to shake this up, and then I were to open it, you see what happens? Because there was so much pressure in the can, it wanted to be released because the pressure in the can was so great. So when I opened the top, I released the pressure, and if you saw, everything came out because those molecules were moving and moving and moving so fast. They were pushing and pushing and pushing. They wanted to be released. So the only way they can be released is you open the can and you release the pressure. What happened with the implosion was that I did the same thing with the molecules. I used the heat. I got the molecules all revved up and going really fast. But instead, when it was a vapor, I actually dipped it into cold water. I took it immediately back to the liquid phase. I reduced the pressure in the can because now I can squeeze the can. I reduced the pressure in the can, but the pressure outside that we feel every day, that we breathe, was greater than the pressure in the can, causing the can to implode. So it's opposite reactions. This one caused an explosion. The other one caused an implosion. That's the power of air pressure. In order to understand what was happening inside the can, we have to understand phase changes and what creates a phase change. What you have previously learned in science class is that there are 3 phases: solid, liquid, and gas. And the way that you move from one phase to the other needs temperature, some type of a temperature change. So we're going to look at the molecular movement, the movement of molecules of water as we change the temperature. I'm going to ask you a few questions and you're going to answer. Here we go. This is our water. So we're going to pretend this is our can, right? So this is our can of water. And look at the molecular movement when it's on cold. The slider is going to go from cold to hot. How would you describe the movement of the molecules? Would you say they're not moving at all? Would you say they're moving slowly? Or would you say they're moving very, very fast? Awesome. They're moving slowly. When it's cold, the molecules are moving slowly. The liquid water will remain liquid water. Look what happens to the molecules as I increase the temperature. Just look at the molecules. Would you say that the molecules are the same as they were when it was cold? Would you say that the molecules are not moving at all? Or would you say that the molecules are moving very, very quickly, and the hotter it gets, the faster the molecules move? How would you describe the movement of the molecules now? Awesome. The molecules are moving very, very fast. That is very important in understanding why the can condensed, why it imploded on itself. So to finalize and summarize everything, you guys helped me so very much in solving this problem. What I did was I controlled the molecular movement. So I took water, increased the heat, therefore I increased the molecular movement, which increased the pressure pressing against the can. Then I immediately put it into cold water, which made the molecular movement slow down. And when the molecular movement slowed down, so did the pressure within the can. But the pressure outside the can that we feel every day, all the time, remained the same. That pressure was greater than the pressure in the can, and it squeezed the can like taking a heavy weight and throwing it on something. It just smashed it because its pressure was greater, because I slowed the molecular movement. And by slowing the molecular movement, I slowed the pressure. I decreased the pressure in the can. That's what caused it to implode. Thank you so much for spending this time with me today, and I look forward to future science experimentation with each and every one of you. Happy sciencing. Dr. D.